Millions of abandoned vehicles are transformed into durable railway tracks through a complex industrial recycling journey.
This process saves resources, reduces waste, and converts aging metal into...
Old cars are collected from scrapyards, urban dumps, and auctions, then transported using heavy-duty trucks. These loaded trucks move toward regional recycling facilities, where large-scale metal processing operations begin immediately.
At the facility entrance, vehicles are weighed, recorded, and sorted based on size, type, and material composition. All remaining fluids, including fuel, oil, coolant, and brake liquids, are carefully drained for safe disposal. Reusable components such as engines, transmissions, batteries, and electronics are removed for refurbishment or resale.
Non-metal materials like seats, plastics, rubber, and glass are separated using manual and mechanical methods. Stripped car bodies are fed into powerful industrial shredders that crush vehicles into fist-sized fragments.
These shredders operate with rotating hammers and blades designed to break steel efficiently and consistently.
Shredded material moves along conveyor belts toward advanced separation systems inside the recycling plant continuously.
Magnetic separators extract ferrous metals, primarily steel, pulling them away from lighter mixed material streams. Remaining fragments pass through eddy current separators, removing aluminum and other non-ferrous metals efficiently and completely.
Air classification systems blow away fabrics, foams, and dust, leaving clean metal fractions behind ready.
Recovered steel pieces are inspected to ensure purity levels meet strict industrial recycling standards requirements.
Recovered steel pieces are inspected to ensure purity levels meet strict industrial recycling standards requirements. Clean steel is compressed into dense bales or loaded loose, depending on downstream processing needs. These steel batches are transferred to on-site or nearby steel mills for melting operations purposes. Inside the steel mill, electric arc furnaces receive recycled steel as their primary raw material.
Extremely high temperatures melt the steel, allowing impurities to float and be chemically removed safely.
Molten steel composition is carefully adjusted by adding carbon and alloying elements for strength control. Molten steel composition is carefully adjusted by adding carbon and alloying elements for strength control.
Once refined, molten steel is poured into continuous casting machines, forming long, solid slabs and shapes.
These slabs cool gradually before entering rolling mills, where thickness and width are precisely reduced. Multiple rolling passes align internal grain structure, improving toughness and fatigue resistance properties significantly overall.
Rolled steel emerges as long rails or rail blanks, depending on final manufacturing configuration requirements. Each rail undergoes controlled heat treatment to achieve optimal hardness and flexibility, balance performance standards.
Precision straightening machines correct minor bends, ensuring rails meet exact alignment tolerances consistently, reliably required.
Surface inspection systems scan rails for cracks, inclusions, or defects using ultrasonic technology and advanced methods.
Defective sections are cut away, while acceptable rails proceed further along the production line smoothly. Finished rails are cut to standard lengths required for national and international railway network systems.
Identification markings are stamped onto each rail, indicating grade, batch, and manufacturing origin details codes.
Protective coatings may be applied to reduce corrosion during storage and transportation stages and periods in handling.
Completed railway tracks are stacked, bundled, and prepared for shipment to construction sites worldwide globally.
This entire recycling chain significantly reduces mining demand and lowers overall environmental impact, footprints, emissions.
Using old cars as raw material conserves energy compared to producing steel from virgin ore.
Water usage and greenhouse gas emissions are also reduced through efficient recycling practices worldwide adoption.
Railway infrastructure benefits from recycled steel because of its proven durability and reliability and record performance. Strict quality control ensures recycled rails perform equally to those made from newly mined steel. This closed-loop system demonstrates how transportation waste becomes transportation infrastructure efficiently. Every stage is optimized to maximize material recovery while minimizing residual landfill waste generation volumes. Advanced automation and data monitoring help maintain consistent output across massive processing volumes in daily operations. Skilled technicians oversee machinery performance, ensuring safety standards and operational efficiency, compliance, stability, continuity, reliability. Maintenance schedules keep shredders, furnaces, and rollers operating smoothly without unexpected interruptions and failures, delays, downtime.
Logistics coordination synchronizes scrap intake, steel output, and rail dispatch timelines efficiently, precisely, continuously nationwide.
By scaling this process, millions of obsolete vehicles gain renewed purpose within rail networks worldwide. The transformation supports circular economy principles by keeping valuable metals in continuous use cycle systems. Recycled railway tracks then support freight and passenger movement for decades of service, reliably, safely.
This industrial pathway highlights engineering innovation combined with environmental responsibility principles.
From scrapyard to steel mill, every step adds value to discarded automotive materials efficiently, sustainably.
The resulting rails form the backbone of railways, connecting cities, industries, and economies, regionally, internationally.
This process continues daily, quietly bring waste into vital infrastructure.
Continuous improvement efforts refine efficiency, safety, and output quality throughout facilities, globally, consistently, systematically monitored.
Research advancements further enhance separation accuracy and metallurgical performance over time, steadily measurably industry-wide adoption.
Policy incentives and regulations encourage higher recycling rates across automotive and rail sectors, nationally, internationally.
Public infrastructure projects increasingly specify recycled steel to meet sustainability targets efficiently, responsibly, and for long-term goals.
This demand reinforces the economic viability of large-scale vehicle recycling systems, globally, sustainably long-term operations. Ultimately, recycling old cars into rails exemplifies smart resource management at scale, industrial, modern, efficient. This method aligns industrial growth with environmental protection and infrastructure expansion goals and strategies planning worldwide.
Through disciplined processes, waste steel gains new life beneath moving trains daily, safely, reliably nationwide.
The recycling journey remains unseen, yet essential to modern transportation systems worldwide, daily functioning efficiently.
Millions of recycled rails quietly support economies while reducing environmental strain, globally, sustainably, long-term impacts. This complete transformation showcases how industry can convert past waste into future progress, responsibly, efficiently.
The process stands as a model for sustainable manufacturing and infrastructure development, worldwide practices systems. This complete transformation showcases how industry can convert past waste into future progress, responsibly, efficiently.
The process stands as a model for sustainable manufacturing and infrastructure development, worldwide practices systems.